Hi, this is Alex from devstories.eu. LangChain v1.0 Orchestration Framework, Episode 15 of 20. To build a truly personalized assistant, it needs to remember that you prefer brief answers, even if you told it that 3 weeks ago in a completely different chat. If you rely solely on standard conversational memory, that preference vanishes the moment you start a new thread. The mechanism that prevents this amnesia is cross-session persistence using the store paradigm. Many developers confuse the checkpointer with the store. Here's the difference. A checkpointer manages short-term state. It remembers a single conversation thread. When the user creates a new chat, the checkpointer starts a blank slate. The store crosses those thread boundaries. It allows your agents to persist and retrieve information globally across all interactions with a specific user. At its core, long-term memory in LangChain is just a hierarchical key-value store. It persists JSON documents. The hierarchy relies on namespaces. A namespace is a sequence of strings that acts exactly like a folder path on your computer. If you want to store profile data, you might use a namespace containing the string users, followed by the user identifier. Inside that namespace, you store items. Every item requires a unique string key and a dictionary representing the JSON value. This is where it gets interesting. Tools interact with this store directly through the runtime context. You never pass the store through your graph state manually. Consider a custom tool named SaveUserInfo. Its job is to capture a spoken language preference. During setup, you initialize your application with a store backing, such as an in-memory store for local testing. Inside your tool logic, you access the store instance directly from the injected runtime configuration. You extract the user identifier from the current context. Then you call the put method on the store. You provide the namespace tuple containing the words users and the user ID. You define a key, like language preference, and finally pass the JSON dictionary containing the value, perhaps Spanish. The store persists this document. Weeks later, the user starts an entirely new conversation. The thread state is empty, but because the agent has access to a retrieval tool, it can call the get method on the runtime store using that exact same namespace and key. It pulls the JSON document, reads the preference, and immediately responds in Spanish. Separating short-term conversational context from long-term factual memory keeps your application lightweight. The checkpointer does not bloat with years of user history, and the state remains clean. The store only loads the specific JSON documents the agent explicitly decides to fetch. Treating context and persistence as two entirely distinct systems is the only way to scale an agent reliably. The checkpointer holds the present, while the store holds the past. That is it for today. Thanks for listening. Go build something cool.